Hey guys, today we're going to be looking at factoring, and this is a pretty important thing that we're going to use all semester, so we're going to break it down into 3 separate videos. So the first video is going to be about factoring out the greatest common factor and factoring by grouping. So if you want to watch that, stay tuned to this video. If you want to skip the ax squared plus bx plus c, which is factoring quadratics, skip to part 2, and if you want to just look at special products, go on to part 3. So for now we're going to look at these first 2 things, which are the basics, which are going to help with the next 2 sections. So now let's get into some examples that explain both of these. So the first type of factoring we're going to look at is factoring out the greatest common factor. So what I've written at the top of the page here is our distribution law that says if I have A times the quantity B plus C, this A is going to distribute into the B, give us AB, plus the A distributes into the C, and gives us AC. So when we talk about distribution, we go left to right, but now when we're talking about factoring, we're going to use the same equals, but now we're going to go right to left. We're going to find some common factor A in both these parts, and we're going to factor it out in front like this. So the goal, find the biggest A that we can, factor it out so that we're left with something simpler inside the parentheses here. So we're going to do that in this example here. So we're going to figure out the biggest A that we can pull out of all 3 of these elements or terms at the same time. So if this is your first time doing this, the best way to do it is to write everything, every piece, every term of each term. So we're going to factor out or factor this as much as possible. So we just have 9x to the 4th. So 9 is 3 times 3. Alright, those are both primes, so we can't go any farther. And then x is, of course, x times x times x. Alright, so we just took this down to its prime components. 9x to the 4th is 3 times 3 times x times x times x times x. And now we're going to do the same thing for the second. Well, 6 is 3 times 2. And then x cubed is x times x times x. And then lastly 12, that's 4 times 3, and then 4 can be broken down into 2 times 2. Alright, we still have the 3, and then x squared is x times x. So by order of operations, this big piece here is the same as 9x to the 4th. This big piece here is 6x cubed, and this piece here is 12x squared. Now again, the goal is to factor out the biggest A that we can from this, so we just see how many things occur in all 3 of these. So a 3 occurs in all 3, so we can pull out a 3. Right. And 2 x's occur in all 3, so we can pull out an x squared. Alright, and now we can automatically tell what's left. When we pull out a 3 and an x squared from here, so we're still left with 2 x's, that's x squared, and one of the 3, so we're left with a 3x squared. Here we put out this 3, so we're still left with 2. Alright, don't forget the minus sign. So the 2, we put out 2 x's, so we're still left with a single x. Then here we put out a 3 and 2 x's, so we're just left with these last 2 2's, which gives us plus 4. Alright, and you can tell there's no more common factors, there's no more variables, because there's no x's in this last term. This has a 2, this has a 3, we can't pull out anything from those at the same time. So this 3x squared is the biggest thing we can pull out from this first expression, and we just factored out the greatest common factor. So one more example about factoring out the greatest common factor. Again, we're just looking for the biggest thing we can pull out going backwards from our distribution law. Biggest thing we can pull out from all 3 terms. So again, I'll do that middle step of writing all the prime factorization of each one of these terms. So 4 is 2 times 2. Alright, a squared is a times a, and we have a single b. 8 is 2 times 2 times 2. A again, or a squared is a times a, and then times a b, and plus 2 is already as simple as it gets, and then b cubed is b times b times b. So again, we just want to figure out the biggest thing we can pull out of all 3 of these, just like it is written and read up here. So there's no a's in this final term, so we know we're not going to be able to pull out an a from all of these. Alright, but each term does have a b in it, so we'll be able to pull out one b, and each term also has a 2 in it. So we can pull out a 2b from every single one of the terms. Alright, our first term now, we got rid of a 2 and got rid of a b, so that leaves us 2a squared. Alright, our second term we put out 2, so that leaves us a 4, and we put out the b, so we also have an a squared. And the last term, we pulled out a 2 and a b, so we're left with b squared. And then we're just going to combine these like terms in here. So we have 2b times 6a squared plus b squared. Alright, and there's no common factors in here. This one just has A's, this one just has B's. Alright, so we can't pull out anything else. So the biggest thing we could have pulled out from the beginning is this 2b, and left with this 6a squared plus b squared. Alright, so this is factoring out the greatest common factor. It'll be helpful in all other types of factoring, so make sure you might not have to do this middle step here of writing everything out. You probably can just go straight from this equation to here. Alright, but get good at factoring out the greatest common factor because it's going to be very helpful in every other type of factoring. So now let's move on to the next section, which is factoring by grouping. So now we want to look at this example to figure out how to do factoring by grouping. So factoring by grouping will use factoring out the greatest common factor, but you can see here there's nothing we could factor out of all four of these at the same time to factor out the greatest common factor. These first three terms have an x, and just these last two terms have a 3, so there's nothing we could factor out of the whole thing. Now what we're going to do, instead of thinking about this as four terms, we're going to separate it and think about it as this term, these first two terms together, and these second two terms together. So this is the main idea of factoring by grouping. We're going to take four terms and just turn it into two sets of 2. And now with these two sets of 2, we're going to do factoring out the greatest common factor. So from x cubed and x squared, we can factor out an x squared. Alright, and that leaves us with an x here and a 1 here. Alright, so make sure when you factor out an x squared from an x squared, you get a 1, not a 0. Sometimes people will think when you factor out everything, you're left with a 0, but you're actually left with a 1. And then from the second set of 2, 3x plus 3, we can also factor out a 3, and we're left with an x. Again, factoring out a 3 from 3 leaves us with a 1, not a 0. Alright, so now we did factoring out the greatest common factor for each set of 2. But again, in this whole thing here, this first term in front of the plus has an x plus 1. The second term after the plus has an x plus 1. So now we can factor out the x plus 1, alright, all together. So we factor that out of this term, we're left with an x squared. And we factor it out of the second term, we're left with a 3. So you can see how factoring by grouping is helpful. We just factor out the greatest common factor from the first two terms, the second two terms, and then hopefully we'll get something that matches in both pieces here, factor that out, and we're left with something much simpler than what we started with. Right, so let's look at another example of factoring by grouping. So this is the next example about factoring by grouping. You can see it's not always going to be as simple as the last example. So this, if we were to just do it blindly like we did last example and group the first two and group the second two, well, the first two, this one has an a times a w, this one has a b times a c, so there's nothing we could actually factor out of these first two. So sometimes with factoring by grouping, you have to move things around first, so then you can do factoring by grouping. Alright, so let's rewrite this as AW plus BC. Alright, then from minus BW, I'm going to write it as plus negative BW. And again, minus AC, I'm going to write it as plus negative AC. So this is the middle step you don't really have to do. It's just, if you're new to moving things around, just be careful with your negatives. So this is going to make sure we keep the negatives where they're supposed to be. So now we just have addition between these four elements, and with addition, it's commutative, so we can move everything around. So now we have a couple of choices we can make. What I'm going to do is move the w's closer together. So I'm going to have AW plus negative BW. So now the things with the W are close to each other, and that's going to move the things with the C close to each other as well. So now I'm going to have plus BC plus negative AC. So now I can do factoring by group. I'm going to take these first two terms and group them together, and these second two terms and group them together. Alright, and the reason I move those, like I just said, both these first terms have a W, so I'm going to factor out that W. That leaves me an A here and a negative B here. And these second two terms, they both have a C, so I'm going to factor out a C. That leaves me with a B minus an AC, or minus an A. So now you might think we're done because this has an A minus B and this has a B minus A. But remember, we have a rule that says that A minus B equals negative times B minus A. So with subtraction, we can't just flip them like we did here. We just flipped these two. Subtraction, we have to flip them and then add an extra minus sign out in front of the whole thing. So for our example, we're just going to leave this W times A minus B. And then we want an A minus B here as well, so we're going to flip that to an A minus B. That means we have to add a negative sign out in front of the whole thing. So this addition here is going to turn into subtraction. Now we have that. expression there. So we added this negative sign and we flipped these two to a minus b. And now in front of the subtraction we have an a minus b, and after the subtraction we have an a minus b. Now we can factor that out. We're left with a w minus a c. And one quick thing that might be helpful when you're doing factoring, especially for the first time, whenever you get to the end, just refoil this and make sure you get back to what you started with. So if we refoil this, the first ones would give us AW, the outer ones would give us minus AC, the inner ones minus BW, and the last ones will give us plus BC. So you can see this blue thing here, we have an AW, we have a minus AC, a minus BW, and a positive BC. So this matches what we started with, so now we know we factored correctly. So this is the idea of factoring by grouping. Again, just get things that are similar next to each other, split them into two groups of two, and hopefully we'll get this common factor here. We had a minus b that could factor out of both of those to get something that's much simpler. So hopefully that's helpful. Those are the basic tools of factoring. The next part 2 of the factoring, we're going to look at factoring quadratics, which are ax squared plus bx plus c, and then in part 3 we'll look at special products.